Alright, today we're going to be talking about solving quadratics by using factoring. Okay, hopefully you guys recall factoring. We've done it before. We're really going to focus on using what we like to call the zero product property. Okay, so what it basically means, okay, is that when you have your two sets of binomials or your two parentheses, that you make each one of your sets of parentheses, you just make them equal to 0, and then you solve for your variable. So notice in the example given here, it says that if you have x plus 3 times x plus 2 equals 0, then you can make x plus 3 equals 0, or you can make x plus 2 equals 0, I should say, and you can make x plus 2 equals 0. All you have to do then is solve for x. So if I was to solve for x here, right, subtract 3 to both sides, I would get x equals negative 3, and if I solve for x here, subtract 2 to both sides, we get x equals negative 2. So that would be the solutions for that quadratic. So another example, okay, let's say I have x plus 5 times 2x plus 6 equals 0. Well, I'm going to take this part and say x plus 5 equals 0, and I'll say 2x plus 6 also equals 0. All I have to do is solve for x. First, I box my variable, cancel what's beside it by doing the opposite. Remember those three letters, B, C, D. X equals negative 5. Next one, same concept. Subtract 6, bring down the 2x, equals negative 6. Last step, D for divide by the number inside your box. X equals negative 3. Okay, so that's basically what we're talking about today. So we're going to use the zero product property to solve each of the following quadratics, and then we're going to check our answers by substituting it back in. Now, I'm going to show you that for one of the problems, just because it's going to take a lot more time and work to check every answer, and it's always easier to check all your answers if you have a calculator. Okay, so number one, notice first thing I need to do is I need to factor it, which means I got to know 3 key letters, and that's my A, B, and my C. That's my A, there's my B, that's my C. Okay, so remember here, we would make that the X, and I have A times C at the top, plus B on the bottom. So A times C, which is 1 times negative 20, is negative 20. B is 1. So now you think about it. What numbers multiply to negative 20 but add up to 1? You guys know that you can do that in your calculator. The numbers are 5 times negative 4 is negative 20. 5 plus negative 4 is positive 1. Well, then I rewrite it into my parentheses. The letter that we're using is X, so that goes in front. I have a positive 5 and a minus 4, and notice I get that from here. Those are those two numbers. The next step is that you take your lead coefficient and you divide your numbers by it, and you reduce. Notice anytime you divide by 1, it stays the same. So that didn't actually change anything. Stays the same. Now, using what we just did in the previous slide, the zero product property, I'm going to make x plus 5 equals 0 and x minus 4 equals 0. All I have to do is solve for x. Box around my variable, subtract 5 to both sides, x equals negative 5. And we get, box my variable, add 4 to both sides, x equals 4. Okay, so this is our solution. Now, hopefully you guys are understanding that whenever I'm saying the word solutions, okay, that it means a few things, right? It means x intercepts, it means zeros, and it means one additional word, roots. All of those words, solutions, x-intercept, zeros, roots, they all mean the same thing, and they all mean where the graph crosses the x-axis. So they're all x-intercepts. Now, we're going to check to see if we did this right by substituting in our answer. So, I have x squared, which I don't need to put in there. X we're going to change to a number. So I have x squared plus x minus 20, and it's supposed to equal 0. Well, what's our first x value we have? -5. So I'm going to plug those -5s into the two blank parentheses because that's what I'm substituting. And then you can work this out. Notice if you have a calculator, you can put all of this into your calculator and see, does it equal 0? If you get 0, then check, that's correct. You know that's right. So if I was to do this math, -5 times -5 gives me 25 plus a -5 minus 20. And when I do that, that does equal 0. So therefore, I know that this is a good answer. Now I'm going to do the same thing with the next x value, which is 4. So let me rewrite that. So x squared plus x minus 20 equals 0. This time I have 4. Alright, let's see what we get. 4 squared is 16, plus 4 is 20, minus 20 does equal 0. So notice this one also works. So those are two solutions, or two x-intercepts, that work for this answer. Alright, so now you understand how to check your work. And the whole point of checking basically means that if I give you answer choices, like for example, if I say answer choice A is x equals 2 and x equals 0. Answer choice B is x equals 1 and x equals 3. Well, let's say you totally forgot how to do all of this that we just did, right, to get the answer. You can always just use your answer choices and plug it in to the problem, right? So you plug in 2 everywhere you see x, work it out, and see, do you get that answer? If you do, then it's got to be right. If it's not true, then you know that's not your right answer. So just food for thought there. So let's go ahead and work out number 2. So I first need to identify my A, B, and C. I'm going to draw my x. I know I have A times C at top plus B on the bottom. My A times C is 1 times 18, which is 18. My B is 11. Two numbers that multiply to 18 and add to 11 are going to be 9 and 2. I have x plus 9, x plus 2 equals 0. Notice because my coefficient is 1, my A is 1, it doesn't really make sense for me to divide by 1 because it's going to be the exact same thing. So I just split this into my two problems. X plus 9 equals 0 and x plus 2 equals 0. Now I just solve for x. Box around my variable, cancel what's beside it. X equals -9, and box around my x, subtract 2 to both sides, x equals -2. So those are my two answers. Those are my two x-intercepts, or my two solutions. Notice you can always check your work. It's always easier and quicker to do that when you have a calculator. Number 3, same concept. First, make sure you identify A, B, and C. A, B, C. There's my big X, so that's A times C up top plus B on the bottom. A times C is -27, because 1 times -27 is -27. B is -6. Two numbers that multiply to -27 and add up to -6. 9 and 3. One of them's got to be negative, and that's got to be the 9. So -9 and 3. So I get x minus 9, x plus 3 equals 0. So now we need to check to see what is our lead coefficient. Remember, if it's a 1, you don't have to do the divide by 1 underneath your numbers because it's going to end up being the exact same thing. So then I can go straight to using the zero property rule. X minus 9 equals 0. And we would have x plus 3 equals 0. Okay, so you just separate them, and we solve for x. Box around my variable. I'm going to add 9 to both sides, so I get x equals 9, and we get, box around my variable, subtract 3 to both sides, x equals negative 3. So these two numbers represent our zeros for the quadratic. Number 4, same concept. Identify A, B, and C. Okay, so now I have my big X, A times C, plus B. A times C is 2 times 5, which is 10. B is 7. Two numbers that multiply to 10 that could add up to 7 are 5 and 2. So that's what goes in my parentheses. So I have x plus 5 and x plus 2 equals 0. Take a look at our lead coefficient, which is our A value, and that's 2. So I have to divide my numbers by 2. Remember, you reduce. Well, technically, can you reduce 5 over 2? Hopefully you realize that you can't, so you take the denominator and you just move it to the front of your letter. So it becomes 2x, and you keep the plus 5. Now in the second parentheses, 2 divided by 2 actually does reduce, and that reduces to x plus 1 equals 0. Now we can follow our zero property rule. I have 2x plus 5 equals 0, and we'll have x plus 1 equals 0. Solving for x. First, I box my variable. Remember, if you need to write the 3 letters down, please write them down for yourself, okay? Box my variable. Cancel what's beside it by subtracting 5 to both sides. Okay, so I get 2x equals negative 5. Last step, D for divide by the number inside my box, and we get a fraction. X equals negative 5 over 2. Now let's see what we get for the second answer. I'm going to box my variable, which is x. All I have to do is cancel what's beside it by subtracting 1 to both sides, and we end up with x equals negative 1. No need to divide. So I have two solutions, right? So that means, remember, here's a little recap, right? Two solutions tells us that this parabola, okay, goes across our x-axis 2 times, right? That's why there's two solutions. Number 5, same exact concept. A, B, and C. I need numbers that multiply to A times C but add up to B. A times C is negative 45. And add up to B, which is negative 4. The two numbers I'm going to use are negative 5 times 5. Alright, now I set up my two parentheses. X minus 9, x plus 5. Take a look at our lead coefficient, which is 3. So I have to divide both of my numbers by the lead coefficient of 3. Then I reduce. X, negative 9 divided by 3 reduces to negative 3. 5 divided by 3, though, can't reduce, so I just take the denominator and move it to the front of the letter. So that becomes 3x plus 5. Now I follow the zero property rule, and I make x minus 3 equals 0, and I make 3x plus 5 equals 0. Now, if you need to write those 3 letters, B, C, D, then please do so, solving for x. First, I box my variable. I'm going to cancel what's beside it by adding 3 to both sides. We get x equals 3. And now let's do the second equation. Same exact steps. First I box my 3x. I cancel a positive 5 by subtracting 5 to both sides. I bring down the 3x equals a negative 5. My next step is going to be to D for divide by the number inside my box. And we get that x equals negative 5 over 3. So my two solutions are x equals 3 and x equals negative 5 over 3. Number 6. Notice what I went ahead and did here for you is I gave you a table so that you can plot these 4 points, because this is the equation or the quadratic equation of the first problem we worked out. So number 1, which I wrote it here already. Okay, so this is the problem right here. I noticed that because my a value is positive 1, I know that this parabola opens up, okay, through those points. I know it opens up. So my a is 1. I know it opens up. Now we need to know what the vertex is in order to figure out the AOS. So I went ahead and did this on my calculator. The vertex is negative 1, comma, negative 20. So what does that tell us the AOS is? Well, the AOS is whatever the x value is. So it's x equals negative 1. My AOS, because it opens up, I know my AOS, or my vertex, sorry, is a minimum. I know that my domain is all real numbers. Remember, that's the symbol. My range, okay, has a bottom point, and the lowest range, and remember, range is your y value. My lowest y value that I go to is negative 20. Alright, so the highest it goes to, notice it never stops going to the top, so that's positive infinity. Remember, we use a bracket with a negative 20 because that point is on the line, and we use a parenthesis for the infinity. Now, the solutions refer to what are the 2 points, okay, that are on our x-axis. And those 2 points are negative 5, 0, and we have another one because there's 2 of them, and that's positive 4, 0. What I want you guys to realize, okay, so if you looked back at your problem number 1, you have those same 2 answers when you worked out problem 1 without looking at the graph. You already knew the 2 solutions. Alright? Last thing I want to talk about is this graph compared to the parent, which is y equals x squared, is it the same, wider, or narrow? Remember what we talked about. Wider it is, the smaller the number. Doesn't matter if it's positive or negative, the smaller the number. So it's usually numbers less than 1, which are proper fractions. The narrower it gets, which is like skinnier, the bigger your number. Remember, your parent has a value of 1. So if this graph also has an a value of 1, then therefore their widths are the same. They didn't change. Notice here I went ahead and graphed a few points for you. So go ahead and take some time to go ahead and do that. I know, so you might need to pause. The vertex for this problem is negative 5, negative 12. Alright, so let's figure some stuff out. My a value is 1. If my a is positive, I know it opens up. Because I told you that the vertex is negative 5, negative 12, I know that my AOS is x equals negative 5. If this graph opens up, then that means that I have a minimum for my vertex. Domain, all real numbers. My range, okay, the lowest my range goes to is negative 12. Remember, range is my y value, which you can also get from your vertex, okay? That's my lowest point, that's why I call it a minimum. And the highest it goes is to positive infinity. Because negative 12 is on the line, I use a bracket, parenthesis on the infinity sign. What are my x-intercepts? I notice that my x-intercepts are negative 9, 0. And I notice I got two of them, negative 2, 0. Notice you can also actually look at the table here and have gotten that. Negative 9, 0, negative 2, 0. One last thing we need to do, if we compare it to the parent graph, which is y equals 1x squared. Remember, when we compare with, we look at the a value. My a value is 1 here. My a value is 1 here. So therefore, they are the same, so their widths are the same. Next one. So here's our problem that we're looking at, which is number 3. All right. And I already have a little table. Notice we can only actually plot a few points. So I'm not sure how crazy big this parabola is. All right, but it looks something like that. I notice that my a value is 1, which means it opens up. The vertex for this graph is 3, negative 36. And what that tells me is that my AOS is x equals 3. If it opens up, that means I know it has a minimum point. The domain is all real numbers. My range has a low point because it's a minimum, and the lowest it goes is negative 36, and the highest it goes is to positive infinity. Bracket on the negative 36, parenthesis on the infinity. Roots is another word for x-intercept, so don't get confused, okay? Another word for x-intercept. And it has two x-intercepts, and those answers are negative 3, 0, and we get positive 9, 0. Notice you can look at the graph here to find it when I plotted it, or you could have looked at the table, or you could have gone back to problem number 3 and looked at what our x values were, and we should have gotten those two answers. Once again, let's compare it to our parent graph, which is y equals 1x squared. So did it get wider? Did it get narrow? Did it stay the same? Well, my a values are both 1s, so that means they're the same, so therefore it is the same width as the parent. Alright, so notice I went ahead and drew my parabola here. I also already identified our a value, which is 2. I know that this opens up. The vertex for this problem is negative 2, negative 1. Okay, notice I can actually graph this AOS. Alright, so that's my AOS right there that I just graphed. And therefore, the equation of it is x equals negative 2. I notice that that vertex is a minimum point. My domain's pretty much always the same, all real numbers. The range, well, the lowest this goes is negative 1. The highest it goes is to positive infinity. Bracket around the negative 1, open parenthesis, okay, with the infinity. My zeros, or in other words, what are my x-intercepts, are, I know there's one obvious one, and the obvious one there is negative 1, 0, and the other one is actually a fraction. Okay, so notice I can look back to my previous problem. This was problem number 4, and look what we got. And the fraction that we got was negative 5 over 2, 0. So let's compare it to our parent. My parent a value is 1, okay, and this graph has a value of 2. Notice this graph has a bigger a value. The bigger the a value, the narrow it gets. So this graph is narrow compared to the parent. So let's try a few more with just dealing with factoring. Notice the first thing that I have to do to this problem is my a value is negative, and my a value can never be negative. So remember, the secret is you just multiply everything by negative 1, and therefore we can make the a positive. So if I multiply that by negative 1, I make it positive 3x squared. The positive 16x would then become negative 16x. the negative 16 will become positive 16 equals 0. There's my A, there's my B, there's my C. A times C plus B. A times C gives me a total of 48. B is negative 16. Two numbers, and if you have a calculator, notice this will be easier for you to figure out. Two numbers and multiply to 48 and add a negative 16 or negative 12 and negative 4. Make my parentheses. X minus 12, X minus 4. I'm going to divide those numbers by my lead coefficient, which is 3. Now let's reduce. So here I get X minus 4, because negative 12 divided by 3 is negative 4. Notice negative 4 divided by 3 doesn't reduce, so I take the denominator, move it to the front. So I get 3x minus 4 equals 0. Zero property rule, I just make each set of parentheses equal to 0. And 3x minus 4 equals 0. Alright, all I gotta do is follow 3 simple steps. B, C, D. Box my variable, cancel what's beside it by adding 4. X equals 4. That's my first x-intercept, or my first solution. Second one, box the 3x, add 4 to both sides. 3x equals 4. Not done. Last step is to divide by 3, and we get that x equals 4 over 3. So notice this graph has 2 solutions. Next problem, notice the first thing that you need to do is take out a GCF. 3x, 1 times 3x, x, 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 x. Two numbers multiplied to 12. 3 times 4, but 4 is 2 times 2. X, x, x. What do they have in common? A 3 and 1, 2, 3 x's. So therefore the GCF is 3x to the third power. That goes on the outside of our parentheses. Everything we didn't circle goes on the inside. I have x squared. I bring a minus sign down because I get that from the problem. 4 equals 0. Now, if you remember last class, we can do this by factoring, or we can just take what's inside the parentheses, x squared minus 4 equals 0, right? And follow what we learned last class about square root. Because notice I only have an a value and a c value. And anytime you have an a value or a c value, you can always use the square root method, which is a lot quicker. So box my variable, add 4 to both sides. We get x squared equals 4. Well, to get rid of the squared sign, I have to just take the square root of both sides. So I get x. Remember, when you take the square root of a positive number, okay, you have a plus or minus solution, and that would be 2. So what I'm saying is that the answers are x equals positive 2 and x equals negative 2. Alright, number 12. Notice it's x squared minus 49, which equals 0. Notice I only have an a value and a c value. And remember the shortcut. If I only have an a value or a c value, instead of, going through factoring and doing a times c and plus b and, saying that, alright, we need two numbers that multiply to negative 49 and then add up to 0. Instead of going through all that work, we could just simply use, our square root method, which we learned last class. So all I have to do is box my variable, which is the x, cancel what's beside it by adding 49 to both sides, bring down the x squared, we cancel what's beside it, equals 49. Notice now to get rid of the squared, I have to take the square root of both sides. When I take the square root, the squared sign goes away and I get just x equals. When I take the square root of a positive number, I know I have two solutions. One's positive, one's negative. Square root of 49 is 7. So in other words, the answer is x equals 7 and x equals negative 7. Okay? So notice you could have done it the other way, though, as well, and we still would have gotten the same answer. Number 13, 2x squared minus 5x equals 88. Now, the first thing that you have to notice is this problem is not in standard form, right? Standard form being ax squared plus bx plus c. So notice the 88 is on the wrong side, so we need to move it. How would we move a positive 88 to the right side? Well, by doing the opposite, which is negative 88. So we cancel them out here, and we end up with 2x squared minus 5x minus 88 equals 0. Now, follow our rules. A, B, C. There's my x. I need two numbers that multiply to a times c that add up to b. A times c, oh man, this is a big number, as negative 176. And b is negative 5. Alright, notice what I did was, because if you guys were in school right now, you'd have your calculator to help you see it. And remember, we go to y equals, and we would type in negative 176 divided by x, and it gives us the list of factors in our calculator. So which option do we think would work out? I think it would be this option right here of 11 and negative 16. Okay, so those are our two values. So I have x goes in front, and I have a x is going to be plus 11 and then x minus 16. Remember, now I look at my lead coefficient, which is a, divide the numbers by 2, and reduce. Can we reduce 11 divided by 2? No, you cannot, so you take that denominator and move it in front. So we get 2x plus 11. But on the other one, negative 16 divided by 2 does reduce. So we get x minus 8. Now you use your zero property, which is what you learned today. And we take 2x plus 11 and make it equal to 0. And we take the x minus 8 and make it equal to 0. And let's see what we get. B, C, D. And don't forget those three simple steps. Box my variable. Cancel what's beside my box by doing the opposite. So I end up with 2x equals negative 11. Last step, divide by 2. And my first answer is that x equals negative 11 over 2. And let's work out the second one. Box the x. I'm going to add 8 to both sides because it was negative. Cancels out. X equals positive 8. So there are my two answers for the last problem. Remember, okay, x-intercepts are called three different things. They are known as solutions, zeros, and roots. And that's basically what we did all today. The whole purpose of today was to find the x-intercepts. Okay, so if they ever say, find the solutions of the quadratic, they're talking about what are the x-intercepts, what are the zeros, what are the roots. Remember, there's always three options. There's either only one answer, there's two solutions, or there are no solutions.